Hi guys, welcome back to my channel. Let's quickly take a look at this interesting problem. So I have this nice trigonometric problem from Saginaw Valley State University Internal Olympics math competition. Find the exact value of sin pi on 10. I've actually solved this problem before, but one of our subscribers commented that the procedures was too lengthy. Hence, I had to research in finding an alternate approach, which is quite simpler. Now, we know pi is 1 radian, which is 180 degrees. So I can actually write the sine of pi on 10 as the sine of angle 180 divided by 10, which is the sine of 18 degrees. So if I say let A equal to 18 degrees, I'm actually going to be having the sine of A, which is equal to sine of pi on 10. Then I shall look at a very special triangle that we are all used to, the right triangle or the right angle triangle. Very popular because it satisfies Pythagoras' theorem. Now, if the angle here is x, because this place is orthogonal or 90 degrees, the angle here has to be 90 minus x. So these two angles are actually complementary. So I can actually write that the sine of 90 minus x is equal to the cosine of angle x. This is because sine and cosine are cofunction, and we are actually using the complementary angle property. So with this, at the back of our minds, I should be able to resolve this problem. Now, if I divide 90 degrees by 18, I'm going to get 5. So 90 degrees divided by 18 degrees will give me 5. So I can then write 5 multiply 18 equal to 90. And 18 degrees is actually equal to A. So you can see what we are trying to do here. So let me put a degree here for clarity. So we're going to be having 5A equal to 90. It's actually an angle, this is an angle, and it's an equation. No need to write them again. So I can write 5A as 2A plus 3A. The reason being that there's a trig formula for 2A, which is called the double angle, and the same thing for 3A, which is called the triple angle. So I can write 5A as 2A plus 3A, which is equal to 90. If I decide to isolate 2A, I'll be having 90 minus 3A. So guys, if I decide to take the sine on both sides, I'll be having the sine of angle 2A equal to the sine of angle 90 minus 3A. Now, from the complementary angle property that we have here, you can see that the sine of angle 90 minus 3A is actually equal to the cosine of angle 3A. That's the punchline. So I'll write the sine of angle 2A equal to the cosine of angle 3A. Now from the addition formula, sine 2A is a double angle. So that is actually 2 sine A cosine A. For this triple angle, cosine 3A, that is 4 cosine cube A minus 3 cosine A. So we work on this equation. Our homecoming is sure guaranteed. Okay? We are going to take care of the left side of the board and move on. So the next thing, cosine A seems to be common on both the left and the right, so I can actually isolate it. So if I isolate cosine A, On the left, I'll be having cosine A, then 2 multiply sine A. Then on the right, if I isolate cosine A, I'm going to be having 4 cos square A minus 3. So what happens here is not a rocket science. Cosine A divides 2 sine A is left. If cosine A divides here, the first term here become 4 cos square A. So if we use cosine A to divide 3 cosine A, 3 is left. That's what we have here. So cosine A will undo each other. We are left with 2 sine A equal to 4 cosine square A minus 3. Now, one of the most famous trig identity is that the sine square of an angle plus the cosine square of the same angle equal to 1. No matter what the angle is. So in this case, we are dealing with angle A. It could be angle theta, it could be beta, it could be any value. So I can write cosine square A in terms of sine square A. That becomes 1 minus sine square A. Then in this our equation here, in place of cosine square A, we shall infuse 1 minus sine square A. So we then have 2 sine A equal to 4 multiply 1 minus sine square A minus 3. So if I distribute this parenthesis, 2 sine A would then be 4 minus 4 sine square A minus 3. Now 4 minus 3 is 1. We're going to be having 2 sine A equal to 1 minus 4 sine square A. This is a quadratic equation in sine A. I can actually solve it directly without using any substitution. So I will rearrange this equation. Becomes 4 sine square A minus, plus 2 sine A minus 1, everything equal to 0. So I can then use the quadratic equation formula to take care of this. So sine of angle A will then be negative B plus or minus B square minus 4AC all upon 2A. So our A is equal to 4. Our B is equal to 2. Our C is equal to negative 1. So we plug them into the quadratic formula. We shall have sine A equal to negative 2 plus or minus 2 squared minus 4 multiply AC, that will be times 4 times negative 1 all upon 2 times 4. Now we do a cleanup. So the sine of angle A is then going to be negative 2 plus or minus 2 squared is 4. Because of this negative sign here, negative 4 multiply negative 1, that will give us positive 16. 2 multiply 4, that's 8. So the sine of angle A would now be negative 2 plus or minus the square root of 20 all upon 8. Now, square root of 20, something as the square root of 4 multiply the square root of 5. So the sine of angle A will then be negative 2 plus or minus, square root of 4 is 2, that will be 2 root 5 all upon 8. Now I can actually factor out 2. So if I factor out 2, I'll be having negative 1 plus or minus root 5 all upon 8. Then I'm factoring out 2, not negative 2. Sorry for that oversight. If I factor out 2, I'll be having negative 1 plus or minus root 5 upon 8. So 2 can divide into 8 to give us 4. So sine A is going to become negative 1 plus or minus root 5 upon 4. So if I split this, it's going to be negative 1 plus root 5 upon 4, or sine A equal to negative 1 minus root 5 upon 4. Now, our A is positive, so we shall take this value. I can actually write this first one to be sine A equal to root 5 minus 1 upon 4. So root 5 is more than 2, so if you express this, or if you take care of this, this will be a positive value. So at the end, sine A is sine pi on 10. Therefore, sine pi on 10 is equal to root 5 minus 1 upon 4. So this is the only solution. We shall reject the second solution because it's a negative value. So guys, that's the end of this tutorial. Please, if you enjoyed it and if you like it, please do well to subscribe and make sure you like and share this video. See you next time and stay blessed.